4.5 deals with parallel and perpendicular lines, and we're going to write the equations of parallel and perpendicular lines. If you recall, if lines are parallel, we know that they have the same slope. So we're going to use that fact to answer some questions in this particular lesson. First, we need to look at a definition, though. And the definition is that of a converse. This says that the converse of a conditional statement interchanges the hypothesis and the conclusion. Hypothesis is basically the if portion of the statement, and the conclusion is the then part. So the converse of a true statement is not always necessarily true. But we have learned that if two non-vertical lines have the same slope, then they're parallel. We know that's true. But its converse is also true. So basically, the converse is saying two lines that are parallel have the same slope. So if they have the same slope, they're parallel. And if they're parallel, they have the same slope. And that is what this is saying right here. So there's your parallel line information. And that's just on the template that I gave you. Okay, so here they're going to ask us to write the equation of the line that passes through a given point and it's parallel to the given line. Well, the first thing we have to do is figure out the slope of the given line. So here's my given line, and I need to put it in slope-intercept form. What I'm going to do is I'm going to move the y to the right and the 1 to the left. That way, I just think it's going to be quicker if I do it that way. So I'm going to get a 6x. To move the 1, I'll subtract it. To move the y, I'll add it. If it bugs you that it's looking like this, go ahead and just rewrite it y equals 6x minus 1. So I can see that the slope is 6. Remember, again, the slope is the m, the rate of change. So I'm looking at this point and this slope, and it says write the equation. Now, since it didn't specifically say write it in point slope form, we're going to always default back to slope-intercept form. That is the most common form that you'll ever see. So recall, there's your x, there's your y. So we go negative 5 equals 6 is my slope. X is also negative 5 plus b. Negative 5 equals negative 30 plus b. I'll add the 30 to get a positive 25 for b. So my equation is y equals 6x plus 25. This would be parallel to this line right here. Let's try one more. Again, I need to solve for the y. I'm going to first subtract the 5x, so I'll get a negative 10y equals negative 5x plus 3. And now I'll divide everything by negative 10. So y equals 1/2 x minus 3/10. Now I don't even care about the 3/10, the minus 3/10, because I am only interested in finding the slope, because my line has to be parallel. My given line and the line that I come up with have to be parallel, so I just care about the slope. So y equals mx plus, let's find b. So 11 equals negative 9/2 plus b. So I'll add the 9/2. And really, I'm taking 11 plus 4.5. So that's 15.5. If you want to write it as a decimal, that's fine with me. So my line that's parallel is y equals 1/2 x plus 15.5. Okay. Next, we're going to go into perpendicular lines because that was the second part of this lesson title. And I'm going to start with the point 5,4. So go ahead and sketch that on your template. And I know perpendicular lines do come together at a right angle. That's the definition of lines being perpendicular. But I want us to discover what happens with the slope. So there's a rule for rotating points 90 degrees clockwise or counterclockwise. And the rule for rotating them counterclockwise basically says that the x and the y's change position. So if I change position, it's going to be 4, 5. But then the new x becomes the opposite. So if I sketch out the point negative 4, 5, I get this right here. And I want to show you, if I connect both of these points to the origin, you can tell that I do have a right angle that's formed. So it's kind of cool what happens with this rotation rule. So what I want to do is I want to see what's true about the slopes of these two line segments that I have here. So this line segment, if I start from here, it's going to rise 1, 2, 3, 4, and it's going to run 1, 2, 3, 4, 5. This line segment, again, if I start from here, the origin, where it starts, I go 1, 2, 3, 4, 5, and it runs a negative 1, 2, 3, 4. There's something significant about the relationship between 4/5 and negative 5/4. We're going to do another one before I come out and let you know what that relationship is, and I'm pretty sure that you've already figured it out, but let's do another one. Here I have -7, -6. Again, I'm going to go ahead and rotate it counterclockwise, and remember I said first we switch positions, so -6, -7, and then we make that new x value the opposite. So it's going to be 6, -7. And when I connect each of these to the origin, again, you can see visually we have a right angle. So awesome. I'll find the slope of each of these. For this one, I'm going to rise up 6 and run over +7. So my slope here is 6/7. For this one, I will rise up 7, but run over a -6. So what is the connection between -5/4, +4/5, +6/7, -7/6? The connection is right here. If two non-vertical lines have this in the same plane, which means we're sketching them on the same coordinate plane, have slopes that are negative reciprocals, I want you to write down, cross off the word negative, and please put in the word opposite. I don't like negative because some of us think that if it's negative, it just always means the answer has to be negative, but that's not what it means. It means the opposite. So if two non-vertical lines in the same plane have slopes that are opposite reciprocals, then the lines are perpendicular. And conversely, if the lines are perpendicular, then their slopes are opposite reciprocals. And now we have to come up with the equations of these two lines that pass through this point and is perpendicular. So again, I need to figure out the slope. So I will go ahead and take this and subtract the 10x, so -5y equals -10x plus 6. I'll divide everything through by -5. And y equals +2x minus 6/5. Again, I only care about the slope, and the slope here is 2. But I want, and I'm going to call it slope perpendicular. I'm just going to put the little, this is the perpendicular symbol, by the way. Sometimes you'll see it as an upside down capital T. Sometimes they will put a right angle in the corner of it. But I want the slope that's perpendicular, so the opposite would be -2. The reciprocal then would be -1/2. Opposite is -2. Reciprocal of 2 is 1/2. So I'm working with this slope. So I'll use my point here. Y equals m times x plus b. Oops, come on. Plus b. So 2 equals +9/2 plus b. So really I'm taking 4/2 and I'm subtracting 9/2 because 2 is 4/2. So that gives me a -5/2. If you want to call it -2.5, that's okay. But ultimately, the equation is y equals -1/2x minus 5/2, or like I said, minus 2.5. This line is perpendicular to this line right here. Let's go ahead and do one more. So I will again put this in slope-intercept form. I will add the 2x, so 5y equals 2x plus 1. When I divide everything by 5, I get y equals 2/5 x plus 1/5. So the original slope is 2/5. The perpendicular slope, the reciprocal, well, first of all, the opposite is negative 2/5. The reciprocal is negative 5/2. And that's what I'll go ahead and use. So I have negative 11 equals negative 5/2 times 10 plus b. Negative 11 equals 2 divides into 10 5 times, so I get a negative 25 plus b. When I add 25 to both sides, I get 14 for the y-intercept. So y equals negative 5/2 x plus 14. That is perpendicular to this given line. Okay. Next, they're asking us to determine which of the following lines, if any, are parallel or perpendicular. Again, it's all based on the slope. So this one, lucky us, line A, the slope is 8. Done with that. Oh, look at this. Line B, they've already put it in slope-intercept form, so the slope of line B is 1/8. And we have to figure out the slope of line C, but they didn't make it very difficult for us. It's almost in slope-intercept form. We just have to go ahead and subtract the 8x, and then we have 2. So the slope of line C is negative 8. Remember, to be parallel, they have to be exactly the same. So none are parallel. And to be perpendicular, they have to be opposites and reciprocals. Well, 8 and 1/8, those are reciprocals, but they're not also opposite. 8 and negative 8 are opposites, but they're not reciprocals. So in this case, none are perpendicular. Okay, there's going to be a couple application problems I want to go over with you. So here it says you're beginning to model a kite design on the coordinate plane as shown. Write an equation that models part A of the kite. So they want an equation of this line. Okay, so we'll say this is line A, so I'll just go y sub A. I need a slope and a y-intercept. Well, my slope is up 2 over 3, so 2/3. And lucky me, my y-intercept is right here, so I don't have to do a whole lot of work. It's just 4. Part B, it says write an equation that models part B of the kite. Okay, so y of line B, again, I need to figure out the slope. It's up 1, 2, 3, 4, and over 1, 2, 3 to the left. And the y-intercept is, again, 4. Oops, let's not forget the x. Do the kites form a right angle? Well, it sure does look like they form a right angle, doesn't it? I'm not going to lie, that picture really looks like they do. But to form a right angle, we have to go ahead and look at the slopes. They have to be opposite reciprocals. They are definitely opposite as far as one of them is a positive and one of them is a negative. However, they're not reciprocals. The reciprocal of 3/2, or I'm sorry, of 2/3 is 3/2. The reciprocal of 4/3 is 3/4. So no, the slopes are not opposite reciprocals. So you can't just go by what it looks like, because I think it looks like a right angle as well, but it's not. Okay, this is the last one. Lunch duty. Everyone at camp takes turns being on lunch duty. You and your friend are in charge of making sandwiches. You can both make one sandwich in 2 minutes. So there's your rate of change. One sandwich in 2 minutes. So your slope is one sandwich in 2 minutes. Your friend arrives 10 minutes earlier than you and starts making sandwiches. So part A, they want us to go ahead and figure out an equation of a line for you and an equation of the line for your friend. So we'll say that you are line 1 and you make one sandwich in 2 minutes and we haven't even started yet. Your friend also makes one sandwich in 2 minutes, but they've been there for 10 minutes. So if they can make one every 2, then they've already made 5 sandwiches, because for every 2 minutes they make one sandwich. So there's the two equations. Part B, how many sandwiches will each of you make in 20 minutes? So you will make a half times 20. So you're going to make 10 sandwiches. And your friend, assuming they've already made the 5, so they're really working 30 minutes, they're going to do half of 20 plus 5. So your friend is going to make 15 sandwiches. How are the graphs related? Well, let's look at the slopes. They have exact same slopes, so that means that they are parallel. So parallel lines. And it says justify. The equations have the same slope. Alright, and that is it for lesson 4.5. I am not far enough ahead in my plans right now to have your assignment written down, so I will go ahead and just tack that on to the website when I get it done.